RIPperoni versus HiJinx and Designing for Damage. Hi! Welcome back. We're not in the owl nest today, we're actually in my apartment. I'm on the hook for some airplane designs, and it's okay. My project is right on schedule, but if I stop working on it for 5 minutes, I will fall 5 minutes behind schedule. That's engineering, baby! So we're here today to talk about HiJinx versus RIPperoni and Designing for Damage, because if you want to play in the big arena, odds are you're gonna take some damage. It is now my stated goal to summarize the entire HiJinx design philosophy while eating a pizza. I got a little one. I can't do a mukbang, but I respect those who can. Envy, really. But I got this from Graffiti Pizza. It's my favorite pizza place in Oakland. Can you see the detail? Yeah. Oh, yeah. There are many strategies you may choose in designing your robot, but we often like to say it's a game of rock, paper, scissors. You can be a brick, like Tantrum, dense, compact, able to absorb hits, get thrown around, and still run. You can try to control the fight with speed and grip like Claw Viper, smothering your opponent. Or you could be a big gangly boy with a sharp tooth bar like Huge. That's just like a couple examples of what could be considered rock, paper, and scissors. For HiJinx, the class we've chosen is essentially scissors. The body of HiJinx is quite long and thin, and the overall focus for the weapon is on reach, the goal of being able to be the first to make the big hit. But you'll notice that on HiJinx, the entire drive and weapon system are contained within an AR-400 monocoque armor and frame. Contrast that with other big horizontal spinners, such as Triton or Tombstone. To be clear, we stan a big spinner in this household, so don't take this as undue criticism, more as a study in the different ways to approach this part of the game. So you'll notice that on both of these robots, Triton and Tombstone, the frame is almost open. Like I can see Triton's castle motors right there on the drive. Compared to HiJinx, Triton and Tombstone are even more weapon forward. That's how they get their big reach. But one of the compromises for having those large bars forward is that after you account for motors and electronics, there's not a lot of weight left, and their bums are kind of vulnerable. But in effect, armor doesn't really play into their design strategy. Instead, they want to obliterate their opponent as quickly as possible without taking a hit. This is scissors, or if you play D&D, this is a glass cannon. So if you are a big horizontal, you want to hit them first and hit them hard. It's also why the most popular strategy for fighting a horizontal spinner is the box rush, aka the Hypershock Special. Will Bales, the last of the arena, first across the box, or a trusty thick plow. In either case, you are shoving your weapon or your whole robot into the horizontal spinner before the weapon has time to speed up. You can put a big chunk of metal out there for the horizontal to hit, like in the plow, and hope that it stalls or breaks their weapon. You want to break your enemy's fist with your face. Last year, Sub-Zero, a very veteran team, tried the plow technique in their fight against HiJinx. That strategy had worked against Valkyrie in Season 5 in their bounty fight, but we removed it, and we won the fight. If you accept that you're going to get hit by the horizontal, there's some risk involved. And for World Championship 7, I personally delivered several plows made by our sponsor, Van Bebber Brothers, to multiple teams who then used those plows against us. Cheeky boys. But when you're dealing with a box rush from a vertical spinner, a spinner that has its weapon mass closer to the axle for a lower moment of inertia and can therefore definitely get up to speed faster than you can, well, you may want to consider what happens when you get hit. In the last half century, there have been advances in composites and plastics for sure, but even though some composites have excellent strength to weight ratio for things like aero surfaces and structures, they do not hold up to impact well. See Formula One. Plastics such as the UHMW that HiJinx and Huge use for wheels can bend out of the way and take a big hit and keep rolling if you get the good stuff. This is what writers call foreshadowing, but they will break down with repeated damage. For HiJinx and for Offbeat Robotics as a team, our design philosophy is thus. Everything on the outside of the robot can be sacrificed in pursuit of a win, including 100% of the armor. The motors, the batteries, the controllers, those are the things that are crucial to protect. Everything else is ablative. All of it. And we've talked about ablative armor in the past on this channel, but at the end of the day, if you're not a brick, it's all ablative. This bit might sound cheeky, but up until our fight with Sawblaze, HiJinx hadn't really taken damage from an opponent, and we're not really optimized to fight a top attack robot, so curious why we keep getting them. It's fine. I'll fight anybody. We have fought both of these robots. So we went 3 minutes in both fights, too. Trying to improve durability. The first time HiJinx fought a vertical spinner, our opponent was Tracer, and we knocked them out in 39 seconds. The second time we fought a vertical spinner, we were yeeted from the arena by uppercut in 33 seconds. In both fights, we took no damage to the chassis, so we had little data on how this design would perform in our application. But we have drawn on prior experience building other robots that have been destroyed. In 2019, when we set out to build the first generation of HiJinx, the goal was to get through a big field of vertical spinners and work our way into the top 16. Hence, we optimized our armor, angles, for fighting verts. The top 16 is still the goal, though we did have some big setbacks in 2022. Also, whenever someone's like, why don't you just build a vertical spinner? Well, fun fact, the first robot that I applied with was a vertical drum spinner, and it was rejected. The first robot that Orion applied with was a vertical disc spinner, and it was rejected. But we both got accepted for things like Rex, Scorpios, Battle Royale with cheese. So at this point, it's like, BattleBots has basically said to us, we know that you can build the weird stuff. Go build the weird stuff. If you look across the field of robots right now, you will see a wide variety of angles, slopes, different shapes for the armor, different wedges, lots of forks, different plows. Insofar as BattleBots is an arms race, it is also an armor race, but with caveat that although we've packed more energy into the weapons nearly every year, the material science that goes into steel armor hasn't really changed much in the last few decades. An alloy is an alloy. Check out my video on steel if you want to hear more about alloys. So the innovation for us is not the material itself, but how we design with it and how we construct it. The angle of the front slope of HiJinx armor is just shy of 110 degrees. The slope of the rear is just shy of 120 degrees. The angle to the nose is about 126 degrees. There are extremely few places where you will find normal angles on HiJinx, numbers like 90 degrees, 45, 30, 60. Because pre-made magnets and fixtures are usually set at those common angles, every time we go to build a new HiJinx, I have to get creative with interior and exterior fixtures to prevent warping and basic human error. So building a robot this shape is definitely playing the fabrication game on hard mode, and I think you're right to ask, is it worth it? Well, let's look at the inside layout on HiJinx. Here we see the drive pod. That is a motor, a gearbox, and an ESC in one package. That's over by the wheel. Above that, our 1/2 battery pack. The detail I want to draw your attention to is the dead air between the top of the angled armor and then everything inside of the robot. There's more than 2 inches of dead air up there. That might seem inefficient, but it's a common refrain that there's no better armor than dead air. What we mean by that is, it is inevitable that a robot, specifically a vertical spinner, will make contact with their weapon on that armor. The further the electronics are from the hit, the more space or dead air there is between their weapon and our electronics, the better. If a vert rips directly through the armor here, they hit nothing. We have a chance to keep going. So the angle of this armor prevents any vertical spinner, especially the boys running up near that tip speed limit, from being able to make a hit to the undercarriage. It is a small but important keep away. They have to be essentially under us to get to the undercarriage. If they are that close to us, it's likely that both of our weapons are off because we've already made contact. Kind of eliminates the chance for the big uppercut. Oh, speaking of uppercut wasn't able to make a hit on our chassis, but they got about the choicest possible hit that they could on our weapon bar. Our bar went into the tip of their weapon and gouged out a chunk, and then their bar caught ours from underneath. That caused the massive throw. I would say it's a 1 in a million shot, but we keep seeing 1 in a million shots on BattleBots, so I'm gonna have to revisit the statistics. There's something really familiar about this pizza robot. Enhance. Oh, hi, Anna! Huh. I wonder if that detail will be important later. Oh, speaking of segues, the pizza coupons. I am not saying that a member of Team RIPperoni, who definitely has my cell phone number, gave it to a bunch of pizza places in the days ahead of the fight and signed me up for coupons. This is not an accusation. I'm saying if you did that, it was very funny. Like, that was very good psychological warfare. I was getting SMS ads for pizza places I have never heard of. Pizza Casa Mia, who is she? Stefano's, Rosati's, Napoli, Domino's. Actually, me and Domino's go way back. We're college friends. That's where you go in College Park when Ledo's Pizza is closed. Ledo's is extremely Maryland. I cannot explain it. Just one day, if you can, go there, eat the buttery crust, thank me later. Anyways, we're here to talk about damage. I'm going to take a moment and dig through photos and see if I have a picture of the head. I already repaired the head and we used it in a later fight, so I may not be able to show that. Hit to the front of the chassis. Tacoed the center gear, but hey, we still got weapon electronics. That'll buff out. So this is the vertical tail, the tail that we used to fight birds. And it was used in the RIPperoni fight. So let's look at the fender. You see this damage? This is all perfectly superficial. This perforated fender design is right out of the brain of our boy Orion Beach. This did exactly what it was meant to do. As RIPperoni's weapon made contact, it was only able to take little bites. The hidden superpower of every vertical spinner is that they're also constant flippers. They can knock you up in the air with any hit, so we want to give them the smallest possible area to bite into. That way we're less likely to get thrown by the hit, and we have a chance to, recover and hit them back. These wee talons out here were inspired by Mad Catter, and they did okay for us. But even this laser cut AR-500, these pieces deformed when they hit floor seams. Like, that's how much energy is behind just driving the robot around. So they did all right, may need to revisit the shape of the material for our application. And now onto the chassis with special guest Orion Beach. Joined by our special guest.
Hey.
We're looking at the chassis. And we have thoughts. So Mr. Beach, where do we start? All right, let's start at this end. So.
Well, there's your problem.
There's your problem.
There. So, yeah, obviously with impacts like this, a blade's going to slide along until it can transfer energy, and then kinetic things happen. So, transferred along, slid into here, got underneath this plate, and just kind of ripped this entire chunk apart. And you can see the sheared off 5/16, 18, 3/8 diameter shoulder bolt that's in there that kind of helps anchor the top armor in this place and helps add structure to this whole thing. And
before we leave this area, considering that we had a drive pod here, would you say that the drive pod behaved like the interior structure? Did this do what you wanted?
Yeah. So the interior structure, the wheel shaft comes in here. The drive pod, you can kind of see its outline is right here. That's all protected and mechanically intact with this kind of damage. The top plate really can't stay on when there's this much bending force. Like, no matter how you bolt this down, the top plate just won't stay on when the robot's this unflat. And you can see the grade 8 shoulder bolts just snapped off in shear. And they're good for a couple thousand pounds of forced shear strength. And you can see this hole of AR-400 just turned egg-shaped.
It just unrounded. It just did a whoop boop.
Yeah, and the rest of the round's over here.
Yeah.
So that used to be down here.
Yeah. So, by design, with this angle sloped forward to catch a vertical spinner hit, did this do what you intended?
Yes and no. So you can see here where the shot coming up glanced, and it didn't hit our battery that's behind it.
Which is a good thing. A very good thing.
But it did eventually catch and dig in right where the weld was and lift this part up. So, unfortunate there. I'd really like to see more of a glancing blow and skipping away and us getting separated as opposed to getting a big energy transfer like this and losing our top armor. But
it did save the battery.
It did save the battery, so that shape does work. We can come around over here, and we can see some similar failure modes where you can see the blade from RIPperoni traveling up and eventually digs in and energy transfers, and then you end up with a big hole here. Again, there's a LiPo battery right behind here that was totally fine. So like this structure did what it was supposed to do. The battery was still in place in here. And then we can move along down here and we can see hole. This is probably the biggest energy transfer when it comes to like how the robot reacted. So this whole side of the robot is twisted down. So this side is twisted down probably 5 degrees or so. And part of that is because we lost this top plate and lost this weld from a previous hit, and we're just kind of twisted this way. The structure of this is supposed to be like a box structure, like a box tube. It's a funny trapezoid shape, but once you lose that top skin, and once you're losing those gussets on it, you're kind of losing that structural shape, and it becomes much flimsier, and that's how we got this big twist.
So when that top panel comes off, we go from a tube, a square tube, to basically a C-channel.
Yeah.
In terms of material strength, a very big C-channel.
Yep. And then you can see some charring from where our speed controller decided it didn't like life anymore.
It didn't enjoy being here.
Yeah.
When this happened, and it said, goodbye. Goodbye, sir.
Yeah.
We are done.
So the drive motor and drive unit could still move and turn, and we're fine. I think we lost the chain on this side, but the speed controller is really what took this side out, just catching on fire. It's the first speed controller that we've caught on fire in a match, and we still didn't set this area is all filled with lipo. You can kind of see the 4 bolt holes of where a battery goes in here. So still no battery lipo fire yet in a HiJinx. This is as close as we've gotten, and it's been a while since we had a electronics fire in the robot, all the way back to season 5 testing when we were trying out those APD controllers.
Oh yeah,
that was an expensive day.
That sure was. And then of course we gifted RIPperoni our aluminum gear from this fight because it became a taco. The hit through this portion of the chassis deformed all the way up. It's just a lot of energy. It's a lot of energy in every hit.
Yeah. Yeah, and they managed to tag all 3 kind of boxes of the robot, each of the drive wings, and then the center section right in front. So it's a pretty damaged chassis. Everything's possible to fix, but I think this one might be easier to just rebuild.
And when we rebuild it, will it be better?
Yes.
Yes.
Always stronger.
Always stronger.
Easier to work on. Easier to make. All those things.
Mm-hmm. But if you would like to buy this, get in my DMs, because it's not going to stick around here for long.
Yeah.
Yeah.
It's got some gourmet damage.
Oh, yeah.
And this one's got the cool chrome
vinyl
on it, too.
We got the chrome vinyl to work on this particular chassis. We'll try again. It'll be great. All right.
Bye.
That's good. This one has mozzarella and ricotta. Ricotta. I don't know how to pronounce that. Ricotta. We'll just go with it. Mid-Atlantic. Did the chassis structure perform as intended? Technically, yes. But this is obviously not the outcome that we want. We were able to last longer in our fight against RIPperoni than Copperhead, so we got that going for us. But we shouldn't have allowed them to hit us, frankly. The extent of this damage would not have happened if the motor controllers and the weapon stack had been behaving correctly, because the whole point of having a big, thick horizontal bar is the joy of shoving it into your enemy, and that's a lot more difficult to do at half power. So let's talk about VESC and interference. A few years back when we first built HiJinx in 2019 into 2020, we had picked out 2 styles of motor controller that we thought were pretty good for the application, which is moving a high inertial load. After some expensive testing that shot flames out of our robot, we decided to go with the Trampas because they didn't do that. At the time, we were one of extremely few teams that were using the Trampa 75-300 motor controller, which had its ups and downs. The biggest downside was that if you ran into some unusual issue with, say, the firmware, there were very few people on the internet who could help you troubleshoot in this kind of application. Like, these are not meant for combat robots. They're made for skateboards. We use them somewhat inappropriately, but we need motor controllers that are brushless, relatively small, but can take over 300 amps. Our friends on Team Hypershock had moved to this controller, so we shared as much of our information about the development as we could. Like, there was one night here in the lab, we could not get hall sensors to work at all. 2 hours later, we turned them 90 degrees and bam, there was signal. They just magically worked. So we shared that information with Hypershock, and they had information to share with us too. Like, that's the power of friendship. Flash forward 3 years, now there are many teams using these controllers because we know they work, kinda. This can make it difficult to buy them, like they run out of stock, but it can also make it difficult to communicate cleanly with them. There were 2 features on the Trampa motor controllers that we initially thought were like killer, awesome, useful things. First was CAN detection, which is something that I've used in other applications, and the other was Bluetooth. We stopped using CAN on HiJinx right away because we bricked one of the motor controllers doing a firmware update over CAN. Don't do that, just so you know. Don't do a direct update. I would have liked to have used the CAN feature, but it turned out to be too fragile, basically. The Bluetooth feature, however, now that seemed legit. So what was really cool about having Bluetooth communication between our cell phone, the motor controller on the robot, was we could turn HiJinx on, walk to a safe distance, and then we could tune the motor controllers in situ on the robot without touching the robot. Like, in terms of safety, I thought this was unbeatable because HiJinx is by its nature a dangerous object. It's capable of ripping metal off of other robots. It's very capable of taking your shins out. So with Bluetooth, we turn on the robot, we walk to a safe distance, do the motor tuning live, roll the clip. All right.
230, 230?
230, 230. I like how it jumps to max immediately.
And stays there?
Yes. With no fault. God.
Okay.
Well,
got the time.
It's doing what it's supposed to. So here at my shop, in a safe containment area far away from humans, this was lit. This was excellent. We could change a single parameter or all of them. We could push the changes over the Bluetooth connection, fire it up, test the weapon, cool down, repeat again and again until it was as smooth as can be, and it was safe because we didn't have to approach the robot to make these changes. There was even a moment in 2020 at my old shop. We were experimenting with HFI settings, and we had a runaway ramping loop. So it would start to cool down, ramp up, down, up, and we couldn't stop the robot with the RC controller, but we were able to turn it off with the phone app. That seemed really cool. But when we got on site, there were not 2 or 4 controllers running at any given point in time. There was more than a dozen, all communicating whilst hundreds of other cell phones and other Bluetooth devices were also online and sending information back and forth. Before we understood the magnitude of this issue, Orion, myself, Paloma, our friend Rory from Monsoon came over to help. Like, we were all pulling our hair out trying to get the controllers to do what they had already been programmed to do at my shop. And when we looked at the app on our phones, it looked like we were connecting and pushing settings. It would work for a moment in the test box, and then it would fail. If you turn it off and on again, everything was different. The numbers we input were gone. We made an assumption about the way that the controllers would receive information, and that included, let's say, a checksum, because when you load settings over a hardline, there is a checksum. There's a final handshake between the devices. Device A, maybe your laptop, pushing the motor settings to device B, the controller. Device B says, I got it. And the loop is closed. That is true on your laptop. It is not true on the Bluetooth app. Oops. So to the user, on the phone, it looks like the 2 devices had a handshake, but the controller could have missed any amount of the data sent over, like any setting, any number, any packet, if you will, could be lost. Now, out in my shop, there's very little interference. San Francisco is a whole bay away, so we had no data on this type of interference until we got there and things went sideways. But wait, there's more. The next clue about the true nature of the problem came when I could see other people's Vesks on my phone app. And at first, I didn't think much of this because we only connect to our Vesks, and we use password protection, so that should prevent unintended connection, right? Right? Nope. Didn't even work. You can override anyone's password protection and talk to their motor controllers at any time the robot is powered on. Our friends on Switchback let us know when they figured out they could talk to our Vesks. Alright, so take a moment and imagine the danger presented in this situation. You're in the battery tent, your robot's powered on, you're flashing an XML file before your next fight, and then somebody outside can just hop onto your controller from their phone, do a bump test, push power to your weapon. You wouldn't even know it until it happens. Now, to be absolutely clear, I don't think that anyone maliciously messed up our controllers. I don't think it was intentional at all. I think there were so many devices communicating this way with so little data integrity that interference became inevitable. Now, with me and my team, we've talked, even argued about the best path forward with motor control. When you've been friends long enough, you can have an argument and then talk it out. It's fine. The fact is, pushing 300 amps continuous isn't something that many brushless controllers can do, while also having a form factor that fits inside of our robots. There is no purpose-built combat motor controller. We're all hacking stuff from e-bikes or out of industry, or in some rare cases, teams have designed their own motor controllers with some success. Speaking of, part of our plan A for next season is a custom, purpose-driven motor controller that can handle high amp draw of a heavyweight weapon. Plan B almost magically manifested RoboGames this year, where we observed another heavyweight robot using motor controllers that can fit in our robot, and they did pretty well. Plan C is we'll keep using the Trampas, but we will never use Bluetooth again. The Trampas can work. They worked okay in Season 5. We even had them dialed in a little bit better in Season 6, so having them just completely fail in Season 7 was like... It was deeply frustrating. Plus, it meant for all of our preseason fights, you didn't get to see the full power HiJinx. And, everyone's disappointed by that. It was just sucked. But now that we understand the full scope of the problem, we can work to solve it. This will not happen again. Would have been great to know before we got to the event, but that is life. Sometimes you get a run of bad luck, and there's no amount of hard work that can overcome it. It's frustrating. It's demoralizing, but you have to keep trying. Okay, kids, fam, friends, come on. Look at me right here. We keep trying. We don't get to quit because it's hard. Listen to me very carefully, because I say this with love. If you are chasing your dream and it's hurting you, if what you're working toward is breaking your heart, if you are burned out, yeah, hun, you should take a break. You should get some rest. You can walk away and come back. But difficulty alone is not a good enough reason to quit. Yeah, this is hard work, so we work harder and smarter, hopefully. We ask for help. We stay on it. If you give up, that's it, game over. But if you keep working, you might get it. Tombstone won a giant nut, which is why I believe HiJinx could too. It's possible. It's possible. It's extremely difficult. I'm optimistic, I'm not delusional. If a horizontal spinner had never won, I wouldn't be pushing us down this path, but I know in my heart that we have not seen the best of what HiJinx can do, and I want to see it. I want to show you. I want peak performance. So we keep working. Anyway. There's always a silver lining. It's a great excuse to eat pizza. Oh, I just remembered. This shirt that I'm wearing was designed by Hotcoin, and they're available for sale on our TeePublic account. I'll drop a link down below. If you want to buy battle damage parts from the HiJinx RIPperoni fight, they will be up on eBay soon. I did give Anna the bent aluminum gear from the Center of HiJinx. It's not the flashiest prize, but true fact, Anna's robot is the first robot that's ever been able to hit HiJinx's weapon stack. So, that's kind of cool. I mean, for her. Please do bid generously on battle damage pieces. Every little bit helps HiJinx suck less next season, and we are building for next season right now. So I want to take a moment and, of course, thank our sponsors, AutoDesk, with software and some machining services, and also continues to supply Orion with a paycheck. AutoDesk, thank you. Van Bebber Brothers, you are the best. Send Cut Send, you rock. Always on time. P3D Creations, unbeatable machining. IMS, so hardworking. Montana Cans, you make us look so good. Anonymous Benefactor, I hope you come back. And Gensace Batteries for giving us that juice. Were you looking at my fridge? Yeah, whenever my friends send me postcards, I put them on my fridge. If you want to help HiJinx and you have a degree in electrical engineering, if you want to help HiJinx in the off-season, there's lots of ways to do it. I mean, first and foremost, you can buy merch. I recently added postcards to the Etsy. So if you go on our Etsy, for the low, low cost of $15, I will send you a postcard anywhere in the world, and it will say whatever you want it to say, as long as it's not something obscene that the US Postal Service would not deliver. So that's your one caveat, cheeky. Stay tuned for our AMA on Reddit on May 2nd. We'll have even more explanations of things that went right and wrong. Okay, I love you, bye! What really is armor? Question for the ages. Put me in, coach. No.